Last week we solved systems of linear equations in two variables, and we used two different methods. We used the elimination method or the substitution method. So today we're going to be solving systems of linear equations in three variables, and the methods are similar to those that we used last week. So first we want to show that the order triple is a solution of the system. So in this order triple, the first number that we see here is going to be x, y, and z. So in order to check if this is a solution to the system, we're going to substitute the values of x, y, and z into each equation, and each equation must be satisfied. So the first equation is x minus 2y plus 3z is equal to 22. So if I let x be -1 and y is -4 and z is 5, and we simplify, we get -1 plus 8 plus 15 equals 22. -1 plus 8 is 7 plus 15 is 22. So 22 is equal to 22. So then we try the next equation. The next equation is 2x minus 3y minus z is equal to 5. So if we substitute the values, x is -1, y is -4, and z is 5. So we get -2 plus 12 minus 5 equals to 5. -2 plus -5 is -7, and plus 12 will give me 5. So 5 is equal to 5 also satisfies the equation. So the third equation is 3x plus y minus 5z is equal to -32. Substitute -1 for x, y is -4, and z is 5. So we have -3 minus 4 minus 25 is equal to -32. -3 minus 4 is -7, plus a -25 is -32. So this also satisfies the equation. So since this order triple satisfied all three equations, then we say that yes, the ordered pair or the ordered triple is a solution to the system. Okay, so the next thing we want to do is solve the equation. So what I like to do is I like to label these equations as 1, 2, and 3. And we're going to choose a variable that we can eliminate. So you can choose to eliminate the x's, you can eliminate the y's, or you can eliminate the z's. So then you're going to pick two equations. So I'm going to pick number 1, x plus 4y minus z is equal to 20. And I'm going to pick number 2, which is 3x plus 2y plus z is equal to 8. So I'm going to go ahead and eliminate the variable z. So if you notice, the coefficient for the variable z in equation 1 is -1, and the coefficient for the variable z in equation 2 is 1. So I can add these two equations. X plus 3x is 4x, 4y plus 2y is 6y, and -z plus z is 0. 20 plus 8 is 28. So I'm going to go ahead and call this new equation number 4. So then what we want to do is use the equation that we haven't used. In my case, I did not use number 3. So I'm going to call that, or number 3 is 2x minus 3y plus 2z is equal to -16. And then we can use any of the other two equations to help us get rid of the same variable. Since my coefficient in front of z is a +2, then I'm going to use equation number 1 to help me eliminate the z. So since we need to have the same opposite coefficients, I'm going to multiply this whole equation by the number 2. My new equation will be 2x plus 8y minus 2z equals 240. So if I add the equations, I get 4x plus 5y, 2z plus negative 2z is 0, plus 24. So what has happened here is we created a new equation, number 5. So equation 4 was 4x plus 6y equals 28. And equation 5, 4x plus 5y is equal to 24. So I can choose a variable to eliminate, and I'm going to eliminate the x's here. So I'm going to multiply by negative 1 to the fifth equation. So I get negative 4x minus 5y is equal to negative 24. And I'm just going to keep the first equation the same. So 4x plus 6y is equal to 28. So 4x minus 4x is 0. 6y minus 5y is y. 28 minus 24 is 4. So then the next step is to back substitute our answer into equation 4 or 5. So I'm going to go ahead and pick equation 4. And wherever I see a y, I'm going to replace it with a 4. So we get 4x plus 24 equals 28. Subtract 24. So we end up with 4x is equal to 4. So x is equal to 1. And then the last step is to back substitute both of these answers into equation 1, 2, or 3. I'm going to go ahead and use equation 1. So x is 1, y is 4, and z is what we're going to solve for. So we get 1 minus 16. So we get 1 plus 16 minus z equals 20. 16 plus 1 is 17. Subtract 17. So we get 3. So we're going to divide by negative 1. So z is equal to negative 3. So my solution is x is 1, y is 4, and z is negative 3. Call this equation 1, 2, and 3. So I'm going to start with equation number 1. And equation number 2. And I would like to get rid of the y's. So I'm going to multiply this equation by a negative 3. So this would become negative 3y plus 12z is equal to positive 48. The first equation is x plus 3y plus 5z is equal to 20. So x plus 0 is x, 3y plus negative 3y is 0, and 5 plus 12 is 17. Z is equal to 68. So that creates our new equation number 4. So the third equation is 3x minus 2y plus 9z equals to 36. So again, you want to use the equation that we haven't used. And then the second equation, I'm going to use it to help me eliminate the same variable, which in this case, we're eliminating y. So I'm going to multiply by 2. So this becomes 2y minus 8z is equal to negative 32. And the first equation was 3x minus 2y plus 9z equals 36. So if I add these, I get 3x. This will become 0 plus z is equal to 4. So this is equation number 5. So we're going to add equations 4 and 5 together, or use them to eliminate our next variable. So I'm going to multiply this equation by a negative 3. So I get negative 3x minus 51z is equal to 214. So if we add the equations, so negative 3 times x is negative 3x, and negative 3 times 17 is negative 51z is equal to negative 3 times 68 is negative 204. The second equation is 3x plus z equals 4. So negative 204 plus 4 is going to be negative 200. And negative 51 plus 50 is negative 50. Divide by negative 50, z is equal to 4. So we're going to back substitute into equations 4 or 5. I'm going to use 4. I'm going to use 5. Subtract 4. So 3x is equal to 0. So x is equal to 0. And then back substitute into one of the other ones. I can look at number 2. So I have y minus 4 times 4 equals negative 16. So y minus 16 is equal to negative 16. Add the 16. So y is equal to 0. So my solution set is 0, 0, 4. Okay, let's try the last one. So systems can be used to help us solve application problems. So the first example we have here. So the example below, a modernistic painting consists of triangles, rectangles, and pentagons, all drawn so as to not overlap or share sides. Within each rectangle are drawn 2 red roses, and each pentagon contains 5 carnations. How many triangles, rectangles, and pentagons appear in the painting if the painting contains a total of 40 geometric figures and 153 sides and 72 flowers? Okay, so we need to come up with some equations. So we know we have triangles plus pentagons. I'm going to use P for pentagons, and rectangles. And these are all geometric figures, and we know we have a total of 40 of them from this number here. The next item they talk about is sides. So I know that a triangle has 3 sides. A pentagon has 5 sides, and a rectangle has 4 sides. And altogether we have 153 sides. And then the last thing they talk about is the flower situation. So nowhere in the word problem do they say anything about triangles and flowers. So the next thing we're going to look at is the flowers. So for the triangle, they don't tell me anything about flowers. So I'm going to make that 0t, plus the pentagon tells us that there is 5 flowers. So I'm going to have 5 pentagon, plus our roses. It says 2 red roses is equal to 72 flowers. So what we have here is 3 equations. So we can eliminate um, the variables. So I'm going to use the first equation, t plus p plus r equals 40. And the second equation, 3t plus 5p plus 4r is equal to 153. Okay, so in order to get rid of the p's here, I'm going to multiply the top by a negative 5 by negative 5. Then we get a negative 5t minus 5p minus 5r equals negative 200. And the bottom equation is 3t plus 5p plus 4r is equal to 153. So if we add the equations, then we get negative 2t, 5p and 5p will become 0, minus r is equal to 7, negative. So then we're going to use the third equation, which was 0t plus 5p plus 2r equals 72. And I'm going to use the second equation, 3t plus 5p plus 4r equals 153. I'm going to multiply the first one by a negative 1. So I end up with negative OT. So we get negative 0t minus 5p minus 2r equals negative 72. And we're going to be adding that to 3t plus 5p plus 4r equals 153. So if we add, we get 3t plus 0t, that's just 3t. The p's are going to cancel. And 4, so negative 2r plus 4r is 2r is equal to negative 72 plus 153 is 81. Okay, so our two equations that we're going to use are negative 2t minus r equals 47, negative 47, and 3t plus 2r equals 81. So we'll multiply the top by a 2. So this would become negative 4t minus 2r equals to, so negative 2 times negative 47 would be negative 94. And then we had 3t plus 2r equals 81. Negative 4t plus 3t is negative t is equal to negative 13. So t is equal to positive 13. So now we can substitute t equals 13 into one of the two equations. So I'm going to use 3t plus 2r equals 81. So 3 times 13 plus 2r equals 81. So 3 times 13 is 39. So subtract 39. So 2r is equal to 42. Divide by 2, so r is going to be 21. And then to find the last one, if T is 13. Okay, so T is 13, R is 21, and we don't know what P is, and all that's equal to 40. Okay, so we have 13 plus P plus 21 equals to 40. 13 plus 21 is 34, plus P equals 40. Subtract 34, so we get 6. So if you notice, 6 plus 13 plus 21 is 40. So we have 6 pentagons, 13 triangles, and 21 rectangles.